Okay, so we'll be looking at the A-star pathfinding algorithm using the Manhattan heuristic. We have our unit in blue on the left-hand side over here, and it is separated from our green destination block on the right-hand side by our nice little red wall over here. Now, the starting point for the algorithm is you take your starting block, which is our blue square, and you add it to the closed list. Once you've done that, you need to look at all the adjacent tiles that are valid and add them to the open list and calculate their F, G, and H scores. We also need to specify that the parent of all these tiles that we are adding to the open list now is our blue starting point. Let's start by doing that. Okay, so the tails of course point to the parent node. Now for the FG and H scores, we're going to start with the H, the heuristic, using our Manhattan heuristic, which says that we're going to look at this tile first. When you start at the tile you're doing the H score calculation for, you just count 10 for each block that you move, ignoring any obstacles. So it's moving from the block to the destination tile. So for this one it's 10, 20, 30, 40. Gives us a 40 over there. And for this one it's 10, 20, 30, 40, 50. And we do the same for each one of these. We can just deduce them from the previous values. 50, 60 for this one. Okay, that's our H score for all the tiles done. Now the G score, which is the cost of moving from one point to another. So the G score for this tile, going from here to there, is 10, because all orthogonal movements cost 10 for us to move. Okay, so it's 10 for that one, 10 for the one directly above, and 10 for the one directly to the left. Now diagonal movements cost a bit more. For us it's going to cost 14. Remember, this is because you're moving further in a square based grid when you're moving diagonally than when you're moving orthogonally. Now to get our F score, of course, we just add our G and H scores together. That gives us a 50 over here, a 64 there, 70, 84, and another 70 here. And then we continue with our algorithm. The next step in the algorithm is to check for all the tiles that are now on the open list for which one has the lowest F score. For us, it's this 50 tile over here. Okay, so we've selected this tile. Step one is to add it to the closed list. Once you've done that, you check the adjacent tiles that are already on the open list. And you check to see if the G score of those tiles is improved by going through our currently selected tile first. In other words, when you start here, you go there, you get a G score of 10. Now from this tile, if you move up, the G score total is going to be 20, which is bigger than the 14. So that's not beneficial. So we're not going to do anything with that. When we go from there to there and then to there, our G score will be 10 plus 14, which is 24, which is again is bigger than this 10. So we do nothing with that. What happens when you go from here to there and to there, and you see you end up having a better G score by going through this tile first, is we have to recalculate all the values for this tile. But we'll have an example like that later, which you can see. Okay, so we're done with our 50 cost tile now. So we need to go back to the algorithm, which says that we need to go look for the tile with the lowest F score again, which for us is now the 64 over here. Step one is you add it to the closed list. Then you need to look at the adjacent tiles that are on the open list to see if their G scores are improved by going through this tile first. Well, it's on 14 plus 10 gives us 24, so no, and we do nothing again. Then the adjacent tiles that are valid, tiles that we can move to, need to be added to the open list and their F, G, and H scores calculated. Now remember, if your unit is allowed to cut corners, then we would be adding this tile at this point. But for the purposes of our example, we're not going to cut corners, so that leaves us just with these two tiles to calculate. Remember, you also need to specify the parent of these tiles every time you add them to the open list. Okay, so we specified parents. Then we need to calculate the H scores for them again. 60 for that one, 70 for that one. 14 plus 10 is 24. Remember, we take the tile we're moving from and we add the G-score to that. 10 plus 14 gives us that 24. 14 moving diagonally to this tile is 14 plus 14 gives us 28. And then we can calculate the F scores. So this one's 84 and this one is 98. And that means we are done with our 64 cost tile. Okay, the next step in the algorithm, we start again. Look for the tile with the lowest F score. For us, we have two tiles with the F score of 70. So which one do we select? It doesn't really matter. In your algorithm, though, it should start with the tile that had the last tile that had added to the open list. We're just going to start with this one over here. Going to add it to the closed list. Now we're going to check again if the G-score to any of the valid adjacent tiles that are on the open list is improved by going through this tile first. So we're going to be here, we're at 10, and we'll see if the one directly above is still on the open list, and our G-score is 10 plus 10 giving us 20, meaning that now our G-score is better if we go through this tile first and then to that one. So when this happens, we need to recalculate all the values for this tile, including, of course, changing the parent. The parent of this tile is now this one. It's got a new, well, obviously the H score stays the same, but it's got a new G score of 20 and a new F score of 90. We then need to do that same check for all the other tiles that are still on the open list. It's 10 plus 14 is 24. It's the same, so we do nothing. 10 plus 10 gives us 20. It's bigger, we do nothing. 10 plus 14 is 24. It's also bigger, we also do nothing. And then we need to add this valid tile to our open list. Specify the parent. The H score for this one is 80. The G is 10 plus 14, 24, giving us 104 as our F score over there. And then we need to continue with our algorithm, which says that we need to look through all the tiles on the open list for the one with the lowest F score, which is now the other 70. So we need to add that to our closed list. Of course, to us this might look stupid because we know that the best path would be to walk that way. The algorithm does not know that, of course. So it's just going to follow its set of rules and work its way through until it gets to the destination. Okay, so we've added this one to the closed list. We need to check again if the G-score when moving through this tile to the other tiles that are on the open list that are adjacent is any better. And we'll see that it's not the case. 10 plus 10 is 20. We do nothing. Then we need to look at the valid adjacent tiles and specify that their parents are this one. And add them to the open list and calculate the F, G, and H scores. That one will be 70. This is 80. The G score will be 10 plus 10, 20. 10 plus 14, 24, giving us 104 there, and 90 over here. Yeah, back to step 1 of our algorithm again, looking at the lowest F score of the tiles that are on the open list. So for us at the moment, we have the two 84s. We need to pick one of them. I'm just going to start with this one. Add it to the closed list. Check if the G scores of the neighboring tiles that are on the open list are improved by moving through this one first. We have 14 plus 14 is 28, so no. 14 plus 10 is 24, it's the same. 14 plus 10 is 24 is the same, and no cigar for the other one as well. So we need to add the valid adjacent tile to the open list and specify that its parent is that one. Give it F, G, and H scores. So it'll have an H of 90, a G of 28, and an F of 118. And we are done with that tile. Then we can look at our other 84. We can add this one to the closed list. check again to see if the G-score when moving through this tile to any of the other adjacent tiles that are already on the open list is improved. For us it's just this one tile on the left. 24 plus 10 is 34, so no. We check again valid adjacent tiles that are not on the open list yet. You need to add them to the open list. So for us it's just this one over here. Specify that its parent is that one. Give it our F, G and H scores. It'll be 50 for this one. 34 over here, 24 plus 10, and then the F score of 84. Okay, so then we go to step 1 of the algorithm again, looking through all the tiles that are on the open list, looking for the one with the lowest F score. For us it's the 84. Add it to the closed list. There are no adjacent tiles that are on the open list, so we just skip to the next step, which will be adding this one to the open list. It'll have a H score of 40, G will be 44, and the F will be 84. Okay, pick the tile again that has the lowest F score that's on the open list. It's another 84. Add it to the closed list. The adjacent tiles need to be added to the open list. Specify their parents. Calculate the F, G and H scores. This one is 10, 20, 30, 30. The G scores will be 44 plus 10 is 54. 44 plus 10 is 54. 44 plus 14, 58. Give us an F score of 84 there, 78 here, and 84 here. Yeah, go through the list of tiles on the open list. Look for the one with the lowest F score. For us now, it's the 78 over here. Check adjacent tiles that are already on the open list to see if their G scores will be improved by going through this one first. It's not the case for either one of those, so we can add the rest of the tiles now to the open list. Specify their parents. Calculate the F, G and H scores. This one is 10, 20 for these two. This one over here will be 30, and this one will be 40. The G scores, 58 plus 14 gives us 72. 58 plus 10 is 68. 72 and 72. The F scores will be 92. 92. This one will be 98. 112. I forgot this one. This one will be 68 plus 10 is 78. Okay, so again, all the tiles on the open list, look for the lowest F score. We have the 78 over here. Add that to our closed list. Okay, now remember that some algorithms or some algorithm implementations would actually stop at this point, because if you look at it, you already have the path. But as they mentioned in the website, there are some cases where if you stop now, you won't actually get the shortest path. Such a case would be when there would be a river running between these two nodes, but no river running between these two. But anyway, we're just going to continue with the algorithm. Okay, so for us, that means to look at the adjacent tiles that are already on the open list to see if their G scores will be improved by going through this one first. And that's not the case for either of those on the left or the right. So we need to move on to the next step, which is to add the valid adjacent tiles to the open list, specify their parents. This of course also applies for our destination tile. There's that one, and these two over here. Also need to calculate again their F, G and H scores. It'll be 10 for you, 10 for you. The G will be 68 plus 14, which gives 82. 92 for F, 82 for you as well, 92 for F. And for this one, the H score will of course be 0. The G will be 68 plus 10, giving us the F of 78 as well. Okay, step 1 of the algorithm again. Look through all the tiles on the open list for the one with the lowest F score. For us, at the moment, that is our destination tile, the 78 over there. And we add it to the closed list. Now, as soon as we add our destination tile to the closed list, we are essentially done. Okay, if you're wondering now where the path is, to get the path, you simply start from your destination here and you look at the parent nodes. So for this one over here, its parent is the tile directly above. The parent of this one is that one. The parent of this one is that one. The parent of that one is that one. The parent of that one is that one. And we go here and there. So that shows you the path that you need to take to get from your starting point to your destination. So then your algorithm, all you need to do is move your unit from one tile to the next until you get to your destination.